Salam alaikum, and thank the organizers for the opportunity to be here and make this presentation. And I want to thank all of the attendees and the participants for what has been a very stimulating discussion for the last 2 days. I'm going to talk about capacity building for technology transfer, and specifically for academic technology transfer and the role that it plays in the knowledge economy. So I want to start off by some quotes, and I think these are important because they illustrate from a number of different areas, from a number of different individuals, why this is important. And I know everybody here knows why this is important, and I hope that this just reinforces how you feel about it and how you want to move forward. So the first is to ensure continuing prosperity in the global economy, nothing is more important than the development and application of knowledge and skills. I believe in innovation, and a way to innovation is to fund research. Innovation distinguishes between a leader and a follower. So I don't know if you recognize this individual. Martin Rees, he is the Astronomer Royal and was president of the Royal Society from 2005 to 2010, a very distinguished individual. This person I'm sure you recognize. And likewise this person. So looking at it from many different perspectives, knowledge as a route to the innovation economy is well documented. And so when we talk about technology transfer, and specifically academic technology transfer, what we want to do is to increase that capacity. And that requires many different things. In terms of why this is important, I'm not going to read through the slides, I'm just going to talk. Why capacity building is important, especially in academic technology transfer. You need to make sure that you have the ability to identify those projects, those innovations that result from research, and recognize whether they have commercial application or not. And even more important than recognizing the commercial applicability of that research, you need to be able to transfer that research into industry for utilization. There are definitely advantages to what you want to do, and you want to make sure that you start with a robust research base, because that is how those innovations arise. Looking at it from a slightly different perspective, there is what I refer to as absorptive capacity versus desorptive capacity. And this requires interaction between universities and industry. It's defined by the culture of the organizations, and it's defined by the industry sectors and the universities in the innovation ecosystem. Now, what is absorptive capacity? It's really the ability of industry or a company to absorb the results of that research and be able to utilize that knowledge to develop products, okay? And it depends on many different things. Desorptive capacity is the ability of an organization to transfer the results of research and knowledge. And you have to have both in order to have an effective innovation ecosystem. If you don't have the ability to transfer it, you're not going to be able to take advantage of it. If you don't have the ability to absorb it, you're not going to be able to take advantage of it. Capacity building is defined or depends on many, many different things. It is a complicated process. And we're not going to get into the details of the entire process, but there are roles that are played in this by government. So we're talking about policies, laws, and regulations. And you heard some of that today. So for example, intellectual property laws are important. Contract laws are important because all of these interactions are defined by contract. Policies are important. Do you have policies that promote the transfer of innovations, or do you have policies that hinder the transfer of innovations? From the industry side, it is also important to take a look at the mission of those particular industry groups. When you take a look at industrial sectors, and if they are primarily involved in manufacturing and producing product and not involved with research and development, then they're going to have a less capacity to absorb research and knowledge from research, because from universities, that knowledge is usually very basic in nature, and the products, again, you heard this morning that universities don't develop products, they develop the hope for products. And so when you take a look at that, you need to understand that when you're on the part of industry, you're not going to get products out of a university. And the same thing goes for universities. What is the mission of universities? Is the mission of a university solely to teach and do research? Or is it to teach, do research, and engage with industry and society? If it's the latter, then you need to have the resources and the skill set to be able to engage with industry and society. Universities engage in basic research. It's usually not applied. And again, the whole concept of academic technology transfer is dependent on a robust research base at the universities. Technology transfer fits into that by looking at that research and being the interface, the front door for the university for industry interactions. The culture is very important. Is there a culture of innovation within the university? And it is not just the ability to create inventions, but it is also the ability to find innovative ways to interact with industry. So when we take a look at the different ways that universities and industry can interact, there is a complex interplay of many things that influence that. The absorptive capacity and the desorptive capacities are defined by culture and the context and the interactions. And the culture, you have openness and flexibility. How open and flexible are industry and universities to working with each other? Commitment to transfer, commitment to receive. Again, it requires a different skill set. The perceived value of what is being developed and what is being transferred. Time scales. Industry typically moves at a lot faster pace than universities. Information asymmetry. And this is, again, going towards the cultural aspects of the universities and industry with respect to what type of information is important, versus in academic research versus applied research. Okay? And then the context and interactions with risk, the ability to technology transfer. Is there a shared vision? And this can differ from project to project. Experience, and really the objectives. And these things are influenced by leadership within industry and within university, and also the different cultural elements of those. And so when you look at it from a slightly different perspective, there are formal and informal channels of how universities and industry interact. So to me, when I think about this, the informal channels are publications, students, conferences, network, the ability to transfer knowledge through general sort of non-formal, information that is publicly available to anybody. And this is a very effective way of transferring that. And then there are the formal channels. And most of the formal channels, when you're talking about university and industry interactions, have to do with technology, academic technology transfer activities. They're research contracts, collaborations, partnerships, licensing, consulting, startups, joint development. All of these require the ability for universities and industry to work together through contractual relationship. And again, all of these are also defined by the common objectives that a university and an industry partner might have for that particular project. Now, focusing specifically on capacity building in universities. With respect to policies, it is very important to have policies within the university that encourage your faculty members, your researchers to interact with industry and to engage in activities that enhance that. So traditionally, universities, when you think about universities and your faculty members at universities, they engage in teaching and they engage in research. And in the US, an individual faculty member has 3 objectives that are part of their mandate: teaching, research, and engagement. Okay? That engagement piece can be defined in many different ways. I remember this was in the mid-90s. I was at the University of Utah, and the Department of Bioengineering was, I think, one of the first departments in the university that said, we will consider the patents that are filed and issued on behalf of our faculty members as part of the promotion and tenure process. Okay? Again, the policy was there not to necessarily enhance, but it didn't discourage people because it took into account activities that they were engaging in and said, yes, we believe these activities have value. If your policies provide incentives for faculty members, they will engage. If your policies provide disincentives, they will not engage. So starting with the policies, you need to start looking at how they're going to influence those interactions. Culture is very important. Is there a culture of innovation? Is there a culture of industry interaction? And that, of course, is influenced by culture in industry, and we'll talk about that later. Expectations. What are the expectations of the university administration with respect to university-industry interactions? What are the expectations of individual faculty members? And this varies from country to country. For example, in the US, research at universities is primarily funded by US federal agencies, National Institutes of Health, National Science Foundation, Department of Energy, Department of Defense, and they fund almost 90 to 95% of all research, academic research. Okay. I think last time I looked, the total research spending in the US of all the federal agencies was about $40 billion. Okay. And I think NIH budget itself was about $25 billion. The models in other countries are very different. So for example, in the Netherlands, most of the research at universities is funded by companies. In Japan, most of the research in universities is funded by companies. So what is the ecosystem that you're dealing with respect to that research funding in Saudi Arabia? And I would argue that if you want to have a culture of innovation, that the research needs to be funded through government agencies, which means that you don't necessarily have obligations to industry for that research, which leads to more freedom to explore basic research and leads to more innovations. And those innovations are not a direct result because your target is not really to create innovations, it's the pursuit of knowledge. And that pursuit of knowledge then results in innovations, some of which have commercial value, others are really advancing the sphere of knowledge. Gateways. What are the gateways through which you interact with industry? It becomes very important to not only establish those gateways, but to resource those gateways and with people who have the right skills and the ability to move things through that gateway. Incentives for collaboration. Are there incentives for collaboration both in industry as well as university? In university, the incentives can be many different. They can take different ways. They can take different shape. One of the ways to do that is to balance the teaching load and the research load and the interaction with industry. One of the ways is to financially reward somebody to do that. And you have to figure out what is going to work here for you. What are the external drivers? In the last 2 days, we have heard about many different external drivers. The need to diversify the economy, the need to create more SMEs that have absorptive capacity, the ability to have more startup companies that create the ecosystem. So all of these, when you think about that, are the drivers for how a university wants to set up a technology transfer operation so that those types of interactions are enhanced. And again, it is very important from my perspective, especially in Saudi Arabia, when you're doing research at a university and it's resulting in innovations, you want to localize those innovations. You don't want those innovations to be transferred outside the country, especially if you want to develop the ecosystem here. So the thing about technology transfer, and this is really looking at it from a much larger perspective. I always define academic technology transfer as the intersection of science, business, and law. And so I always tell my friends I know a little bit about a lot. And I don't know much about details about a lot, but I know a little bit about a lot. Because you have to span these skills in order to be effective, okay? And it's really, if you think about it, it's the process through which knowledge is transferred for commercial use for public benefit. And when you think about it in that way, and you think about what it takes to transfer that knowledge, you basically have discovery, review and assessment, commercial applications, you protect and market, and then you have many different activities as a result of that. In order to be effective for that, you need to make sure that your technology transfer operations are staffed appropriately. Do they have the right background, skills, and training? Okay? It's not enough to just be technically astute in an area. You have to have technical skills, business skills, and some legal skills. You don't need to be a lawyer, you don't necessarily need to have an MBA, and you don't necessarily need to have a PhD, but you need, the key thing is, and I think this one sentence, in my opinion, sort of sums it up, it is the ability to understand the research and identify the business opportunity of that research, and it be able to transfer that business opportunity to an industry. Okay. I know lots of people who are very skilled in individual pieces of that, and I think from a technology transfer perspective, that skill set becomes very, very important. What are the resources that are required? We heard this morning and yesterday about technology gap funds, intellectual property funds. Those are resources that are very important in order to facilitate the process of technology transfer. We also heard about prototyping. We also heard about the ability to have technology gap funds, as I mentioned, so that you can actually look at a project and say, can we advance this project so that the technology readiness level is appealing to industry? Industry, by definition, is risk averse when it comes to early stage innovations. Okay? So you have to advance that technology to a point where you can either license it or create a startup which can raise capital, or it becomes the basis of a collaboration or a partnership with an industry partner. Funding and support. Again, it is very important for university administration to realize that if this technology transfer function is going to be an important aspect of their mission, that it needs to be resourced and funded in terms of the type of people that are hired and their ability to conduct business. I talked a little bit about some of the programs that are important for technology transfer. And again, we can talk pretty much for a full day about what's on each of these slides. And I'm going to briefly sort of go over some of these areas. So faculty and student education. Faculty and students are going through a process in terms of their education. Faculty teach, students learn. There's a pedagogical process that takes place. And when you're talking to faculty or potential faculty entrepreneurs, they need to understand what it means to be an entrepreneur. Because faculty, by definition, are not entrepreneurs in the sense of a business. They may be entrepreneurial in their research, but that's a different skill set. Okay. Students are generally entrepreneurial in nature, but when they go to university, we teach them to not be entrepreneurial and that they need to look for a job, okay? Because that's what we're training them for. So you need to have programs in the university that are targeted towards faculty entrepreneurs and student entrepreneurs, for those of that group who want to participate in that process. You have to take a look at the type of research that is being conducted and how that research affects interactions with industry. Is it research, or are you just getting materials from industry, testing them, and providing a report back? You know, that's not necessarily research, but it's a valuable interaction. When you're thinking about how those interactions are structured, that all of those aspects of research, research services, joint collaborations need to be taken into account. Interesting story that I had. We put into place one major collaboration with industry, and it was to create a database of patient information for cancer patients and identify which mutations those cancer patients had. And the reason it was important to this company was that they wanted to use this database to select patients for clinical trials. And they were talking to us, we were talking to them, and it was a big project. It was going to take 5-6 years and multi-million dollars. What we did was we had some initial conversations, and then it was obvious that the expectations from industry were different than what we had. And so I got a group together from the university, faculty member, myself, a couple of other people. We got on a plane and we flew to the company. And the company was very surprised. They said, "You're coming here?" And we said, "Yes, we feel that this project is important enough that we should come to you and we could figure this out." So we sat in a conference room for a day, and at the end of the day, we had an agreement. So again, it takes an understanding of what you're trying to achieve and how you want to achieve it. There's a process in the US, and it was actually started in habit bases in Europe called easy licensing. So these are licenses to university technologies for which no negotiation, needs to take place. The terms are defined, the terms are easy. Most companies accept those terms without any negotiation, and so the key idea there is identifying those things that are resulting from research that you can do that easy licensing around. Technology gap funds we've talked about. When you're advancing the technology readiness level, it's important to understand the amount of funding that's going to be required for each project. And selection of those projects becomes very critical. So there's a whole host of best practices associated with technology gap funds. For example, having an external advisory board. You don't want to make those decisions internally because internal decisions can get politicized very quickly. Okay? You want to have an external review of entrepreneurs, industry, intellectual property lawyers, and maybe even faculty members from other universities who participate in that. springboard funds. Now, springboard funds are really interesting because 10 years ago, a fund like this didn't exist at a university in the US. The springboard funds are targeted towards faculty entrepreneurs or student entrepreneurs to help them establish their startup company. These funds provide legal consulting, business consulting, market consulting. They provide limited amount of money for travel, for networking events. They provide limited amount of travel for conferences. And they also provide access to networks. Okay. Startup programs. Again, when you take a look at startup programs, what is important? So springboard funds are obviously important to a startup program, but there are now programs that have made it seamless for those startups to transition from the university using springboard funds into a university-owned or university-affiliated incubator or accelerator, which enables that company to grow to a point where they can establish their own facilities. And then the reason why it's here is that the university can actually facilitate and mentor those startup companies through the entire process. Because, again, faculty members are great researchers. They're not good businessmen usually. And so you have to provide them with the ability to succeed. Seed investment becomes important. We've talked about venture capital. You've heard about SBIR and STTR grants in the US. There are similar programs in other countries. Establishing those types of programs for startup companies or small companies becomes very important. And that addresses a particular valley of death. And I was on a panel discussion about 8 years ago with several colleagues and representatives from the venture capital industry. And one of the individuals who was representing a fairly major fund in the US said, well, we call ourselves venture capitalists, but honestly, we've taken the word venture out of our title by our actions, because we really don't put money into early stage companies. We like to put money into later stage companies to increase the likelihood of return. So again, when you have that, or when you have a lack of venture capital, universities can create their own seed funds. And this doesn't require a lot of money, and the seed funding doesn't need to be large. So if you provide $100,000 or $200,000 to a startup company, that is a lot of money. And you have, of course, you take equity in return for that, just like any other investor. But that $100,000 or $200,000 can mean the difference between failure and success. Okay? Now, there are barriers. The first barrier, as I've mentioned, is cultural. There is a not invented here syndrome in companies. If we didn't create it, then obviously it isn't good. And that's still there. It's less, but it's still there. And that varies from company to company. It varies from industry sector to industry sector. The counterpart to that in universities is a not sold here culture. Oh, we're academics. We believe in academic freedom. Working with industry is not something that we should engage in because it doesn't fulfill our mission. And It pollutes the type of research that we do, so we don't want to sell our research. Overcoming these obstacles is challenging and it takes time. I remember early on in my career having several discussions with faculty members, department chairs, deans about engaging with industry doesn't mean that you are subverting your research. All it means is you're looking at a parallel path, okay, to having your research benefit the public. Yeah. If you publish something that's great, everybody will know about it, but nobody will develop a product around it because everybody knows about it and everybody can do it. On the other hand, if you publish and we patent something at the same time or protect it with copyrights or other forms of intellectual property, then you're creating that monopoly of intellectual property that is valuable to a company. Risk. Any transaction between university and industry, of course, carries risk. There's the technology risk. Is this technology going to work? Well, we don't know that yet because it's very basic in nature. And you have to make sure, like I said, using gap funds or other means, collaborative joint collaborations, partnerships to advance that technology to a point where it's de-risked enough for industry. Financial risk. What is the cost of that project to industry? Okay. Industry has an obligation to its shareholders or its owners. They're looking to make a profit at some point. If that is going to require so much money that it puts that at risk, they're not going to engage. Or maybe the reward is going to be so big that they can actually justify that. Again, those interactions need to be discussed and need to be understood by both sides. What's the intellectual property risk? Well, we're engaged in basic research. Are we going to be able to protect this? Can we create that fence around this innovation so that we can develop the commercial products without our competitors doing that? And intellectual property is really interesting because for the longest time, many people, many universities in the US, across the world, file for patent protection in their local jurisdictions. US universities would file patent applications in the US, Saudi companies would file in Saudi Arabia, Indians in India. Those types of intellectual property protection don't have as much value as filing across international markets. And it becomes very expensive very quickly. So the typical cost, for example, to file a patent application in the US is around $10,000. If it's a complicated patent application, which usually pharmaceutical or biotechnology patents are, that cost can be as high as $25,000. Okay? That's just the beginning. Now, if you want to file internationally, you file what's called a PCT application, and you can do that for the same amount of money. But you get to a 30-month deadline, and then you have to choose which countries you want to pursue that patent application in. And the number of countries that you choose is going to affect the cost. So let's say you choose 10 countries across the world, then all of a sudden you have to pay almost $50,000, $60,000, or $70,000 at that point to pursue those patent applications. And then of course, you're paying the attorneys all of the legal fees to work on that. So very quickly, you can be spending, $200,000 a year. Is it worth it? So you have to be very careful in making that decision, and you also have to be very selective in moving projects forward along that pathway, because resources are limited. What's the opportunity? What's the market need? Is this innovation solving a problem? If it's not solving a problem, you're not going to be able to license it. High transaction costs. I mentioned earlier that universities and companies move at different timescales. If a company, for example, is ready to move forward and you have to go through a multiple approval process, then that is a disincentive. I remember about 15 years ago, I saw the example of a license agreement from a university that shall remain unnamed. There was, in order to execute the license agreement, in order to sign the license agreement, there was one person signing on behalf of the company. Guess how many people were signing on behalf of the university? 10. It's not going to work, okay? I mean, just routing that agreement for signatures to 10 people can take months. And by that time, that opportunity may have passed you by. Again, this goes into the policies of the university in terms of how you want to interact. I have worked with other universities where the agreement has to go through a legal review, but only after it's been finalized, okay? And it typically goes to the university's general counsel, and it stays there for months because the general counsel is involved in so many different things. And that goes into the time value of money. So, in sort of ending, getting to the end of my remarks here, there are challenges. There's no doubt there are challenges. But what you're seeking to do is really enhance your regional and national innovation ecosystems. And this is going to require a cultural shift, both on the part of universities and on the part of industry. And you need to take a long-term view. So some of the statistics here, I hope you can read them on the slide. These are collected through the Association of University Technology Managers. And I think this is 2015 data, and this is a collective of 25 years of data collection. That in that period of time, there have been 3.8 million jobs created as a result of academic technology transfer, okay? 153 new drugs have been introduced as a result of academic technology transfer. Last year, as a result of academic technology transfer, there were almost $29 billion of products sold, okay? So when you look at these statistics, you can start realizing how impactful university technology transfer can be. Now, in the US, we've been doing this for 40 years, and I'm not going to say that that's the right way to do it, because we have made many mistakes along the way, and we need to make sure that when you're looking at this and when you're adapting that technology transfer mechanism, you need to make sure that you are doing so for the ecosystem that you want to establish here. So, in conclusion, universities need to be open, as do industry. They need to understand the risk profiles of the research to innovation pathway, the innovation to commercialization pathway. They need to reduce transaction costs. They need to facilitate communications at all levels. This is from technology transfer to faculty, faculty to department chair to dean, dean to administration. And there is a challenge on how you balance basic versus applied research, okay? And looking at it from a government perspective, just last slide. You cannot force innovation. You need to facilitate it. So the policies need to make sure that you facilitate these types of interactions. You need to invest in funding research, and you need to invest in certain types of infrastructure. So with that, I'm going to say thank you. I believe I'm a little over the time, but I'm available for questions